Hello friends, in this video we'll learn how to solve a traveling salesman problem, and in the problem statement you can see that a salesman has to visit 5 cities A, B, C, D and E, and the distance between the cities is as follows, and it is given in the form of a matrix, and the values in the matrix are given as the distance between the city A to city B is 3 kilometers, the distance between the city C to city D is 6 kilometers, the distance between city D to city A is 2 kilometers, and similarly all the distances are given. And you should also note that the distance between a city from that city to itself is marked with a dash, as it is a nil, it has no value. So the traveling salesman problem says that we have to select such a route for the salesman that the salesman starts from his home city, city A, and passes through each city once and only once, and return to the home city in the shortest possible distance. So now what we need to do is, for the solution, first we'll apply the row minimization. So now for the row minimization, we select the minimum element in each row of the matrix and subtract it from all the other elements. So the resulting matrix will look like in the row 1 the minimum element is 2, so we'll subtract 2 from all the members of row 1. We'll put a dash here, and then 3 minus 2 is 1, 6 minus 2 is 4, 2 minus 2 is 0, and 3 minus 2 is 1. Now for the row 2 the minimum element is again 2 here, so we'll subtract 2 from all the members of row 2. So 3 minus 2 would be 1. Here we'll put a dash, and here 3 minus 2 will be 5 minus 2 will be 3, and 2 minus 2 here will be 0, and 3 minus 2 will be 1. Similarly for the row 3, the minimum element of the row 3 is 4, so we'll subtract 4. Like 6 minus 4 is 2, 5 minus 4 is 1. Here we'll put a dash, and 6 minus 4 is 2, and 4 minus 4 is 0. And for the row 4 the minimum element is 2, so we'll subtract 2 from all the members. Like 2 minus 2 is 0, 2 minus 2 again 0, 6 minus 2 is 4, here we'll put a mark dash, and 6 minus 2 is again 4. In the last row the minimum element is 3, so we'll subtract 3 from all the other elements of the row 5. So 3 minus 3 is 0, 3 minus 3 is again 0, and 4 minus 3 is 1, and 6 minus 3 is 3, and here we'll put a dash mark. So after we have applied the row minimization, we need to apply the column minimization. For the column minimization, we'll select the minimum element of each column and subtract that element from all the other elements of that column. So the transformation, we'll again write the matrix. So here you can see that then in column 1 the minimum element is 0, so performing subtraction will not make any difference, so we'll copy all the values of the column 1 as it is. Similarly in the column 2 the minimum element is 0, so making subtraction or performing subtraction will not make any difference, so we'll copy the values as it is. But you can see in the column 3 the minimum element is 1, so we'll subtract 1 from all the other members of this column. So 4 minus 1 will be 3, 3 minus 1 will be 2. Here we'll put a dash, and 4 minus 1 is 3, and 1 minus 1 is 0. And in the column 4 we'll copy the values as it is, as the minimum element is 0. Again in the column 5 the minimum element is 0, so we'll copy the values as it is. So now as you can see that we have performed both the row and column minimization, we need to calculate the penalties of all zeros. To calculate the penalties of all zeros, we find the minimum element of row and column of corresponding zero and add them. So like we'll perform this, like for this zero the minimum element of its row is 1 and the minimum element of its column is 0, so 0 plus 1 is 1, so the penalty of this 0 is 1. For this 0 the minimum element in its row is 1 and the minimum element in its column is 0, so 0 plus 1 is 1, so the penalty associated with this 0 is 1. For this 0 the minimum element in its row is 1, the minimum element in its column is also 1, so 1 plus 1 is 2, so 2 is the penalty associated with this 0. For this 0 the minimum element in its column is this 0 and in its row is also 0, so 0 plus 0 is equal to 0. Similarly for this 0 minimum element in its row is 0 and in its column is also 0, so 0 plus 0 will be 0. Similarly for these two zeros the penalty will also be 0. But for this 0 the minimum element in its row is 0 and in its column is 2, so 0 plus 2 will be equal to 2, so the penalty associated with this 0 is 2. So now what we need to do is we need to select the maximum penalty and cancel the corresponding row and column to make the assignment. So now we know that the penalties of these two zeros is equal to 2, so as it is a tie, so ties needs to be broken arbitrarily, so we select this 0 and we consider it with the maximum penalty. So we strike off the row corresponding to this 0 and column corresponding to this 0 and we make the assignment C to E. So now as we have made the assignment, we need to write the reduced matrix. To write the reduced matrix, what we'll do is we'll not consider the row corresponding to C and the column corresponding to E, and we'll write the resulting reduced matrix as A, B, D and E, and here A, B, C and D. Now we'll write the values in this matrix, like from the distance between A to A is, we'll put a dash here, from A to B it is 1, from A to C it is 3 and from A to D it is 0. From B to A it is 1, from B to B it is dash, and from B to C it is 0, and from B to D it is 0. Now here in the D the values will be 0, 0, 3 and dash. Now for the E, the distance between E to A is 0, the distance between E to B is 0. Now one thing we need to keep in mind is that as we have made the assignment from C to E, city C to E, we cannot come back from city E to city C. So we'll put a dash mark here, as we'll not consider the distance between E to C. And from E to D the distance is 3. So now we need to make sure so before proceeding further, we need to make sure one thing, that all our rows and columns have at least one zero. So we see that all our rows have at least one zero, but in the columns, the column 3 doesn't have any zero. So what we need to do is, we'll find the minimum element in the column 3 and we'll subtract that element from all the elements of that column, that is column 3. So after we can say it a transformation. So the matrix would look like A, B, D and E, and here A, B, C and D. So first of all we need to write the column 3. So for that, we see that in the column 3 the minimum element is 2, so we'll subtract 2 from all the members of all the other elements of column 3. So 3 minus 2 will be 1, 2 minus 2 will be 0, and 3 minus 2 will be 1, and here we'll put a dash, and we can copy rest of the values as it is. So now, as you can see that all our rows and columns have at least 1 0. So now we can proceed to calculating the penalties associated with the zeros. So for calculating the penalties, you can see that for this 0, the minimum element in its row is 1 and the minimum element in its column is 0. So 0 plus 1 will be 1. So 1 is the penalty associated with this 0. For this 0, the minimum element is in its row is 0 and the minimum element in its column is 1. So 0 plus 1 is 1. For this 0, the minimum element in its column is 0 and the minimum element in its row is 0. So 0 plus 0 will be equal to 0. For these zeros, we will find the penalties. Like for this 0, the minimum element in its row is 0. The minimum element in its column is also 0. So 0 plus 0 is 0. And for this, the minimum element in its column is 0. The minimum element in its row is 0. So 0 plus 0 is equal to 0. Similarly, for these two zeros, the penalty is again equal to 0. So as you can see that the maximum penalties in here is 1 and that corresponds to these two zeros. So we'll break the tie arbitrarily and we'll make the assignment from corresponding to this 0. So we'll strike off row 1 and column 4. So we have made the assignment A to D. So again we need to write the reduced matrix. To write the reduced matrix, we will not include the values corresponding to the row 1, that is to corresponding to the row with the city A and to the city D, column associated with the city D. So the resulting reduced matrix will be B, D, E, and here we'll write A, B and C. So the values for this matrix will be, from B to A the distance is 1, from B to B it would be a dash mark, and from B to C it would be 0. But you need to take care of that D cannot go back to A, as we have made the assignment from city A to city D. So we will put a dash here, and from D to B it is 0, from D to C it is 1, and from E to A it is 0, from E to B it is 0, and from E to C it is a dash, as we cannot go back from E to C, as we have already made an assignment of C to E. So now you can see that all our rows and all our columns have at least one 0. all rows and columns have at least 1 0. So we can directly jump to the calculation of penalties associated with the zeros. So the penalty associated with this 0 can be calculated as the minimum element in its row is 1 and the minimum element in its column is 1. So the 1 plus 1 is equal to 2. So penalty associated with this 0 is 2. For this 0, the minimum element in its column is 0 and the minimum element in its row is 1. So 0 plus 1 is equal to 1. For this 0, the minimum element in its column is 0. The minimum element in its row is 0. So 0 plus 0 is equal to 0. And for this 0, the minimum element in its row is 0 and the minimum element in its column is 1. So 0 plus 1 is equal to 1. So now you can see that the maximum penalty here is 2. So we need to make assignment corresponding to this 0. So we'll strike off row corresponding to B and the column corresponding to city C. So here we have made the assignment B to C. So again we need to write the reduced matrix. To write the reduced matrix, we will not consider the row corresponding to B and the column corresponding to C. So the resulting matrix will be D, E, A, B. So from D to A, we will put a dash. From D to B, we'll write 0. From E to A, we'll write a 0, and from E to B, we'll again put a 0. So now you can see that as each of our column and row have at least 1 0, we can directly move to the calculation of penalties associated with these zeros. So the penalty associated with this 0 would be 0, as the minimum element in its row column is 0 and in its row is nothing. You can take it as 0 or something. So the penalty associated with this 0 will be 0. The penalty associated with this 0 will be 0, as the minimum element in its column and row is 0. So 0 plus 0 is equal to 0. And for this 0, the penalty will again be 0. So you can see that we cannot make the assignment from D to A, as you can see dash here. So we cannot make assignment here. So assignment from D to A is not possible. And we can see that we can make an assignment from E to B. Sorry, as we cannot make any assignment from D to A, we will have to make the assignment from D to B. So we will strike off this row and this column. So we can make the assignment D to B, as the assignment from D to A is not possible. And we are left with the assignment from E to A. So we will write this assignment, and we have no other option. So up till now we have assignments as C to E, A to D, B to C, D to B, and E to A. By using all these 5 assignments, we can conclude that the route that the salesman needs to follow is A to D, D to B, B to C, C to E, and from city E back to city A. And the total minimum distance will be 2 plus 2 plus 5 plus 4 plus 3. I have written these distances between these cities. From city A to D, the distance is 2. From city D to B, the distance is 2. Thus from city B to C, distance is 5. From city E C to E the distance is 4, and from city E to the city A the distance is 3. I have written these distances from the original given matrix of distances, and by calculating the sum of these distances we will get 16. So the total minimum distance is 16 units. So that's our final solution. I hope you'd find this video helpful. If it is so, please press the like button. Don't forget to subscribe. Happy learning, and share this video as much as you can with your friends. You can also follow Happy Learning at Google+, Facebook, Twitter, Pinterest. Links to these pages and boards are given in the description below. Thanks a lot for watching. Happy learning.